Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So on today's lesson, we're going to start off with trigonometry, right? And in the next sequence of lessons that I'm going to be uploading on my channel, we're going to be looking at the following topics. We're going to be looking at how we work with positive and negative angles on the Cartesian plane. We're going to be looking at how you simplify trig expressions. Okay, we're going to be looking at how you prove that the left-hand side is equal to the right-hand side if you're given a trig equation. We're going to be looking at the general solution, right, and how we solve it. And then we're going to be looking at solving problems in 2D and in 3D. Okay. So now let's look at this question, right? Let's say you're asked to simplify, the given expression without using a calculator. There's a lot of things that are happening in this expression. We've got co-functions. We need to be able to know how to, reduce, the given expressions, taking in consideration that we're given reduction formulas, right? So there's a lot going on here, right? But before we even look at simplifying this given expression, I just want us to talk about positive angles and how they work in the Cartesian plane. And I just want us to play around with the Cartesian plane and just understand how these reduction formulas, right, are basically formulated. Okay, so now I'm going to need you guys to listen to me and listen to me carefully because I'm going to be explaining positive angles, right? What are positive angles? How do you work with them? What are negative angles? How do you work with them, right? So let's say, for example, you're given a question where you asked to measure, okay, the size that this line makes, or the angle that this line makes with the positive x-axis. So if you had to determine this angle, we already know that when you have to measure angles, right, you would start by measuring from the x-axis and then you would move, right, in an anti-clockwise direction to determine what that angle is, right? And because we're moving in an anti-clockwise direction, we already know that that angle will be positive, right? So maybe that angle, if we were to approximate, maybe it will be like 30 degrees, 40 degrees, 50 degrees, approximately, okay? It will be positive. Those values like 30, 40, 50, whatever it is. I'm just approximating, okay? The key here, when you're measuring positive angles, we are moving in a anti-clockwise direction. Okay, same here. If you had to measure this angle, right? So let's say you've got this line here, okay, and you want to determine, let me just erase this, okay, the size of this angle. So if you're moving from the positive x-axis to that line, what is the size of that angle beta? Okay, the first way is that we can just measure it if we were required to measure. Let's say, for example, it's 120 degrees. So because we're measuring from the positive x-axis and we're moving in the clockwise direction, okay, we know that that angle will approximately maybe be like 150 degrees or 160 degrees or whatever. Positive 150 degrees or whatever. I'm just approximating. Or positive beta. Okay, but now another way that we can even get this angle beta is by calculating it or finding it in this way, okay? So you need to just pay attention to me, right? You can also do this to get this angle beta. Okay, so now we can also measure from the x-axis. Remember, when you're measuring angles, you always need to start from the x-axis and you either move in a positive, in a clockwise direction or anti-clockwise direction, okay, right? But remember, we want to determine what is angle beta. So to determine what is angle beta, and let's say you're starting from the x-axis, the negative x-axis, and you're moving in an clockwise direction, we already know that that angle that I've just indicated there, this angle is going to be a negative angle. Why? Because we are moving in a clockwise direction. Okay, so that means that to get this angle beta, right, we can just also just take this. We can just say 180 degrees minus this angle will actually give me angle beta. Okay, so the angle beta can be calculated by just taking 180 degrees minus theta. We're just taking it the way that it is, minus theta, because we know that whatever angle that we'll measure there is just going to be a negative angle. So it's going to be 180 minus that negative angle will just give us our angle beta. Okay, let's continue. Let's say, for example, you're asked to determine this angle, okay? You're asked to determine, okay, let's say you're starting from there to there. What would be the size of this angle? Number one, okay, it's going to be very easy actually to determine the size of this angle, right? We can maybe, actually here, you wouldn't be able to measure it. Okay, if you think of it, you wouldn't be able to just measure using your protractor, right? The size of this angle. But there's another way that we can also determine the size of this angle. We already know that from here to here, this is a full 180 degrees. Done. But now we want to determine what's the size from there to there. Okay, because we know that if we take the 180 plus that size there, we'll be able to determine what that angle is, right? Let's call this angle beta again, right? So we want to determine what is the size of that angle beta. So in this case, right, to determine the size of angle beta, what do we do, right? We already know that from there to there, it's already 180 degrees from there to there. We just want to determine what's the size of this angle. We'll call this theta. Okay, and because remember, when you're measuring your angle, you start from the x-axis, whether it's the positive x-axis or negative x-axis. We're starting from the x-axis, and in this case, we are moving in a clockwise direction. So that means it's a positive theta, it's a positive angle, meaning that the size of angle beta, right, is actually equal to this 180, because we've passed the 180 mark, 180 degrees plus theta. That's how we'd get our angle beta. Okay, now let's continue. You're given this angle, okay, starting from the positive x-axis, you're going all the way around, and you want to determine what is the size, we want to call this, of angle beta. Right, again, how do we determine the size of this given angle? Again, you start, we can just measure to make your life easy, because you can't be measuring with a protractor like that unless you've got that protractor that does a complete revolution. Okay, what can we do in this case, right? You can just measure from the x-axis. Remember, when you're measuring out angles, you always start from the x-axis, right? And you go towards your line, right? And then what are we noticing about that angle? Because we are moving in a clockwise direction, that tells us that this angle is going to be a negative angle, right? So that means that for us to get angle beta, right, what do we need to do? We are just going to take, because we haven't reached 360 yet, we are just going to say, to get angle beta, it's just going to be 360 degrees minus this theta. And that's going to give us that angle beta. So that is how they create your reduction formulas, okay, using this concept, okay, because I'm sure you've seen in your classes before, right, the following reduction formulas, okay, where you are told that in the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant, right? Okay, and then we know that using this rhyme, all students take care. So this rhyme helps us remember where our trig functions are positive, right? We know that in the first quadrant, all the trig functions are positive. In the second quadrant, only the sine is positive. In the third, only the tan, and in the fourth, only the cos is positive, right? So now, based on what I was basically explaining, right, that's how we got to, if you wanted any angle, okay, that's in the second quadrant, we use the reduction formula of 180 degrees minus theta, okay? 180 degrees minus theta, okay? Because we haven't reached 180 degrees yet. Any angle that falls in the second quadrant is an angle that is less than 180 degrees, hence 180 minus theta. Now, what's happening in the third quadrant? Okay. Also, I explained with that beta example, right? Any angle that falls within the third quadrant, right? We haven't reached the 270 yet, but we've passed 280. So it's just going to be that 180 degrees plus theta quadrant, okay? Any angle that is there, right, is 180 plus theta. Okay, taking into consideration the fact that we measured the angle from the x-axis and we moved towards the line to give us that theta there. Now let's continue. What's happening in the fourth quadrant? any angle that falls in the fourth quadrant, right? We haven't made that 368 degrees, né? Right? So it's an angle that is less than 360 degrees. Hence why we say it's 360 degrees minus theta. Okay, good. So now let's continue now, right? And let's work with now if the 90 degrees minus theta, 90 degrees plus theta. Okay, how do they get that? Okay, so now we already know that any angle that falls in the first quadrant is an angle that is less than 90 degrees. Okay, it's an angle that is less than 90 degrees, right? Okay, so in other words, another way that we can actually look at this, right? If we wanted to determine this angle here, right? It's just another way that we can see it. If you wanted to determine what is the size of this angle there, okay, right? What can we do? Okay, let's actually call this angle beta so that we're not confused. Maybe we wanted to determine what is the size of this angle, right? How can we determine this angle, right? We can also determine this angle by taking 90 degrees, okay? We can just take the 90 degrees because we know that, okay, we haven't made a full 90 degrees yet, okay? So we can just take 90 degrees and you minus this angle there, right? Okay, so what's that angle? It's angle theta, right? So if you take 90 degrees minus that angle theta, you'd actually get angle beta. Okay, so we can actually even refer, okay, we can actually refer to the first quadrant as well as the 90 degrees minus theta quadrant, okay, because any angle that falls in this quadrant is an angle that is less than 90 degrees, right? And lastly, also what's happening here, if you wanted to also, determine this angle, right? You can also look at it like this. So I've got my angle there. Maybe you want to determine what's the size of this angle, right? So we can also look at it like this. Maybe we wanted to determine what is this angle beta there, right? So for us to determine that angle beta, we already know that in this case, from here to here, we've already made that full 90 degrees. Do you guys agree? Okay, we're just trying to determine what is the size from there to there. Let's call that theta. Okay, so for us to determine that now, this angle beta in this case, we can just say it's 90 plus theta. Okay, plus that theta there. Okay, so that is how they basically come up, or how these, reduction formulas, right, are formulated. Okay, that's where the whole concept comes from. Okay, so I just wanted to explain that so that we all understand what's happening and where they come from. Okay, so we can also refer to the second quadrant as the 90 degrees plus theta quadrant, because an angle that falls within the second quadrant is an angle that is more than 90 degrees, okay, 90 plus theta, or it's an angle that is less than 180 80 degrees, 180 minus theta. Okay, so I hope we all understand where all of these reduction formulas come from, because it's very important that we understand and you understand what I was doing with those diagrams, because when it comes to the negative angles, right, it's the same concept. It's just that in that case, we're just dealing with negative angles. All right, so I hope this makes sense, okay, because this is what we're going to be using to help us reduce the expression that was given to us there. Lastly, what I also wanted to explain was the concept of co-functions. Okay, so before we also look at this problem, I want to talk about co-functions. What are co-functions? Okay, so co-functions are a pair of trig functions, right, that have equal values, okay, when applied to complementary angles, right? So that sounds like it's a lot to take on, okay, but now let's think of an example, right? Okay, right, so we said it's a pair of trig functions that have equal values when applied to complementary angles. So now let's think of this. Let's think of sine of 30. Okay, sine of 30 degrees is actually equal to cos of, what's the complement of 30? Okay, the complement of 30 is 60. Okay, because we know that complementary angles add up to 90 degrees. Okay, so when you're talking about co-functions, we are talking about functions that have the same values, right, when performed on complementary angle. Okay, let's look at another example, right? Sine of 40 degrees is going to be equal to Now, what's the complementary angles I just mentioned? It's angles that add up to 90 degrees. It will be cos of, okay, 40 plus what will give me 90 degrees? 40 plus 30 degrees. Okay, so these angles are co-functions. Okay, these trig functions are co-functions, okay, because they've got equal values when applied to complementary angles. Let's look at another one. Also, sine of 45 degrees is equal to cos of 45 plus what will give us 90? Cos of 45 degrees. So in other words, what's basically happening here, right? So if, for example, you're given sine of 90 minus 60 degrees, you can actually reduce that to cos of 60, okay? Sine of 90 minus 60 can also be reduced to cos of 60 because 90 minus 60 is a sine of 30 degrees and sine of 30 is equal to cos of 60 degrees. Okay, so it's fine. I know that this can be a bit of a lot to grasp, okay, but then that's how we basically, that is what a co-function is, okay, so that when I talk about co-functions, you just understand that I'm just talking about trig functions that have the same values when applied to complementary angles. Okay, so now it's fine. Now let's look at the co-function identities that you guys need to know. Okay, let's look at the co-function identities that you guys need to know. Okay, so let's look at the first one. If I'm talking about sine of 90 minus theta, okay, how can we reduce this co-function? Okay, what are we supposed to do? If you're given cos of 90 degrees, I'm forgetting the degrees, minus theta, how are we supposed to reduce this? If you're given sine of 90 degrees plus theta, okay, how are we supposed to reduce that? And if you're also given cos of 90 degrees plus theta, how are we supposed to reduce that? Okay, so now the first thing that we're supposed to note, right, is that when you're given such, right, we already know that, okay, the co-function of sine is cos, okay, because they have the same values, right? So if I'm saying sine of 90 minus theta, I already know that, okay, I'm supposed to have an answer of cos of theta. If I'm given cos of 90 minus theta, I already know that I'm supposed to have sine of theta as my answer. If I've got sine of 90 plus theta, I already know that I have to have cos of theta as my answer. And if I'm given cos of 90 plus theta, I already know that I have to have sine of theta as my answer. However, we are not done. We need to now deal with the sides, okay, right? So now you need to ask yourself, if you're working with 90 minus theta, you need to ask yourself, in which quadrant am I on? Okay, so if I'm working with 90 minus theta, you already know that you're in the first quadrant. And in the first quadrant, what's happening, right, is what's happening with the trig functions. We know all of our trig functions are positive in the first quadrant, right? So we already know that, okay, even though we've got our answer here of cos of theta, this is actually just positive cos of theta. So you can even leave it as cos of theta, but I'm just leaving it like this for the purpose of my explanation. Now let's continue. We've got cos of 90 minus theta. Again, you ask yourself, right, in which quadrant am I in? 90 minus theta is in the first quadrant. And in the first quadrant, all of my trig functions are positive. It's going to be positive sine of theta. Let's continue. We've got sine of 90 plus theta. In which quadrant am I on? I'm in the second quadrant. And what's happening in the second quadrant? Only the sine function is positive. So because we were given sine of 90 plus theta, that means that I'm just going to write that as a positive cos of theta. Let's look at the last one. We've got cos of 90 plus theta. 90 plus theta is in which quadrant? It's in the second quadrant. And what's happening in the second quadrant? Only the sine is positive. So that means that because I'm given a cos, right, it's cos positive, because I'm given a cos of 90 plus theta, it's just going to be negative sine of theta. Okay, so that's just the way we can just look at it to help us now remember these co-function identities, right? The first thing that you're supposed to do, you look at the function that's given to you. We've got sine of 90 minus theta, okay? So you ask yourself, In which quadrant am I in? I'm in the first quadrant, right? Is sine positive or negative in the first quadrant? It's positive. What's the cofunction of sine? It's cos. Continue. Cos of 90 minus theta. In which quadrant am I in? I'm in the first quadrant. Is cos positive or negative in the first quadrant? It's positive. What's the cofunction of cos? Sine. Continue. Next one. Sine of 90 plus theta. In which quadrant am I in? I'm in the second quadrant, right? Okay. Is sine positive or negative in the second quadrant? It's positive, right? What's the cofunction of sine? Cos. Cos of 90 plus theta. In which quadrant am I in? Second quadrant, okay? Is cos positive or negative in the second quadrant? It's negative. What's the cofunction of cos? It's sine. So this just takes practice, okay? It just takes practice, and then you'll basically remember these cofunction identities. Okay, now that we've discussed everything, I know that it's a lot, okay, right? Okay, I'm sure that we all understand this. I'm sure that we've all seen this, but I just wanted you guys to see where they come from, okay? So now that we understand what's happening, where they come from, we can simplify the given expression, right, without using a calculator. Okay, so now let's look at the following expression. They're asking us to simplify without using a calculator. So already here, there are things that you're supposed to, that like you need to be having light bulb moments, right? You can see that here we're given a cofunction. Okay, that's a cofunction. Cos of 90 minus theta. So we need to look at our cofunction identities here to help us reduce this trig function, right? And then here, what's happening? We're just going to be using the reduction formulas, right, that we formulated on our Cartesian plane to help us reduce, okay, the 180 minus x, the 360 minus x, 180 plus x, right? So we just want to reduce these given, reduction formulas so that you just have, simple trig functions like sine x or cos x or whatever, right? We just want to reduce it to the most simplest form. Okay, so now let's continue. Let's find the answer for this, right? So here, we're going to leave the 2 as is. So that's just going to be 2. What is sine of 180 minus theta, right? So the first thing now, we're going to just look. 180 minus theta is in which quadrant? Okay, so 180 minus theta, right? It's in the second quadrant, right? And in the second quadrant, is sine positive or negative? It's positive. So we can just reduce that to sine of x, okay? Because sine is positive in the second quadrant. Let's continue. You're given cos of 360 minus x, right? In which quadrant are we in? Right, so we're in the fourth quadrant. And is cos positive or negative in the fourth quadrant? Cos is positive. So we can reduce this. So I'm just going to open brackets like this. We can reduce this to cos of x. Let's continue. Cos of 90 minus x. So here, you just need to remember that I'm given a cofunction here, right? This is a cofunction. So you need to think back to your cofunction identities and how you're supposed to reduce them. So how do I reduce your cofunctions, right? So if you're given cos of 90 minus cos of 90 minus x, right? Remember, you ask yourself, in which quadrant am I in? I'm in the first quadrant, right? I'm in the first quadrant. And in the first quadrant, is cos positive or negative? We already know that in the first quadrant, all of your functions are positive, right? So it's just going to be positive, right? And then what's the cofunction of cos? It's sine x. Okay, so to reduce that, we'll just write it as sine of x, sine x. Okay, let's continue. Cos of 180 plus x. In which quadrant are we in? 180 plus x. We're in the third quadrant. And in the third quadrant, only 10, right, is positive. Only the 10 function is positive. So that means that you'll have a negative cos of x. Okay, so we've reduced this, right? Looking at our Cartesian plane, right? Looking at our cofunctions, we understand what's happening there, right? So we can simplify this further by looking at, can certain functions cancel, right? So here we can see that, okay, the sine x can cancel with the sine x because we're just multiplying there, so they can cancel. And then the cos x can cancel with the cos x, meaning that your final answer will be 2 over negative 1, and 2 divided by negative 1 is just equal to negative 2. All right, So I know that this was a bit, it was a lot, okay? But I needed to explain this part so that when we get to, working with your negative angles, right? You guys understand what I'm doing there, okay? So please stick with me, right? And listen to the explanations that I'm giving to you guys. I promise you, they will definitely benefit to you, okay? Because we're looking at things at a deeper level so that you guys are understanding deeply what it is that you're doing so that it's not a matter of us cramming all of these reduction formulas, but you are able to understand where they come from because you understand what's happening with positive angles and what's happening with negative angles, right? So I'm going to stop it here for now, right? And then in our next lesson, we're going to be looking at this question where you're asked to simplify the given expression, tan of 180 minus x, cos of 360 minus x, plus cos of 90 plus x, divided by cos of 90 minus x times sine of 90 plus x. So still here, we are just dealing with positive angles only because we've got 180 degrees, positive 180 degrees, positive 360 degrees, positive 90 degrees, positive 90 degrees, positive 90. We are just dealing with positive angles. So we are still going to be looking at the Cartesian plane that we worked with, right? And how we formulated our reduction formulas from there. Okay, so I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.